Welcome to qnawire.
Hi guys, so this is again a problem of a cylindrical capacitor which has inner cylinder of radius Ra. Let's say this radius is Ra given to us. So Ra equals 2.2 mm, and it has outer spherical shell of radius, let's say Rb. Rb equals 3.5 mm. The length of the cylinder is given to be, so the length L is given to be 2.8 meters. So the cylinder is 2.8 meters long. And with this information, we are required to find the capacitance per unit length of the cylinder. So since we know that the capacitance for the cylindrical shell is given by the formula capacitance C equals 2 pi epsilon naught L divided by natural log of outer radius Rb divided by inner radius Ra. So this is the capacitance for the cylindrical capacitor, and we are required to find the capacitance per unit length. So it's going to be C over L, which is going to be 2 pi epsilon naught over natural log of Rb over Ra. So let us substitute the given values. So we have C over L, the capacitance per unit length. We have 2 times pi times epsilon naught, which is 8.85. So it's 8.85 times 10 raised to negative 12. That's the epsilon naught divided by natural log of the outer radius, which is going to be 3.5 mm, divided by the inner radius 2.2 mm. Note that we haven't converted our radius from millimeter to meters because it's a division, and when you divide the quantities of the same units, you don't have to worry about the units as such, because the units also get divided and the divided quantity has no units. So you can very well write the radius in millimeter itself. So 3.5 millimeter divided by 2.2 millimeters. And if you do the calculation, you find that the capacitance per unit length for the given cylindrical capacitor comes out to be 119.76 picofarad per meter. So this is the capacitance per unit length for the given capacitor. Good. So we have found the first part. Now let us solve the second part. So the second part, we need to find the charge on each capacitor, on each the inner and the outer region of the capacitor. If the voltage on one of the parts is 350 millivolts times larger than the other part. To be exact, it's given that the potential of the inner conductor is 350 millivolt higher than that of the outer conductor. So the inner conductor, so if I redraw my, so this is at higher potential, high voltage. So the inner conductor is at high voltage, and the outer conductor is at low voltage. So since it's given that the inner conductor is the voltage on the inner conductor is 350 millivolts higher than that of the outer conductor. So the potential difference between these two conductors is very conveniently can be written as 350 millivolt. So that is the potential difference between the two conductors, the inner and the outer conductor. So from the previous value of the capacitance per unit length, if you just multiply length on both sides, you'll find the capacitance of this capacitor. So C equals the value which we got here, which is 119.76. So write 119.76. It was picofarad. So I'm going to write 10 raised to negative 12, which is going to take care of my picofarad term, times the length of the cylinder, which is given to be 2.8 meters. So if I calculate this quantity, I'll get the capacitance for the given cylindrical capacitor comes out to be 335.33 picofarad. So this is the capacitance for given cylindrical capacitor. So once you have found the capacitance, then since for the capacitors we know that the charge Q equals C times V, and if you substitute the values here, 335.33 times 10 raised to negative 12 times voltage, which is 350, it's millivolts, so 10 raised to negative 3 volts. You'll find that the charge is going to be 117.36 picocoulomb. So this is my charge. To write it explicitly, so the charge Q is going to be 117.36 picocoulomb. So since the inner conductor is at higher potential, so it's going to have positive charge, so it's going to have positive 117.36 picocoulomb, and the outer conductor is at lower potential, it's going to have negative 117.36 coulomb of charge. So this is the charge distribution on conductors. Thank you very much.